All right, good morning. If you are absent today, you need to turn to the yellow packet, page 8, liquid volume. We're looking at volume. Volume is volume, so whether it be regular objects or liquid, it's still going to be a measurement of how much space something takes up. Can't use a ruler because you'll make a mess. You need a graduated cylinder. The units are going to be a little bit different too. You could use centimeters cubed because volume is volume, right? But in this case, we're going to use something else. You know this word already because you buy these from the supermarket. If you buy soda, we always measure soda in a different unit. A metric unit. What is it, Andrew? Liters. So liter is the basic unit for volume. That's liquid. Liter always has a capital L. In this class, we don't want to measure liters because it's so much liquid. Our liquid is going to be a little liquid. Smaller. So what's the smallest liquid that's 1,000 times smaller? We're going to put a little word in front of it. What do you think you're going to put in front of it, Gavin?
Water.
You're going to put this in front of it. Milliliter. So we will always use milliliters in science. Little m, big L. Got it? We're always going to round to the same place so we don't get confused. Always in science, every number you ever do, except when you get to earth science, you're going to round to the thousandths when you do eccentricity. But in science, when you're measuring, because our instruments can only measure so far, we have to always measure to the nearest tenth thumb. So it's going to be to the nearest 0.1, 0.1 milliliters. Most of the time, you're going to have 0.0, but we're measuring to the nearest tenth thumb. Our units. This is regular volume. Liquid volume is the same thing. They're going to be equal to each other. So if I say 1 milliliter, that's the same as 1 centimeter cubed. Same exact thing. So 1 milliliter would be a small little block like this big. And then 1 milliliter would be a tiny bit of liquid water. Did you leave something, maybe?
In my binder.
Do you see it? Like 1 milliliter is this much water. Tiny bit. I don't see it. Anybody see Christian's binder?
I didn't see it.
No, that's just a milk. What color is it, baby?
It's yellow.
Yellow?
Yellow.
Where did you go next period?
I'm kind of not too.
It's not math either. Where'd you go after that? Oh. That's so strange. It's not in your backpack? I don't see it, baby. I'll keep my eyes open. All right. So, 1 milliliter is the same as 1 centimeter cubed. One little cube. Remember this yesterday, this block? It was a different color. The one you had? It was 64 centimeters cubed. That means it's made up of 64 little 1 blocks. 64 of them fill up this whole thing. So that's about the size of 1. What does 64 look like? 64 would look like 64. This is 60 up here. Well, you found it? Just water. The reason why I put, this is 64. I did it good. This is 64 milliliters, which is about the same size as this. Why does it look different? Why does this look different, Chastity? Yeah, one's a liquid, and the cylinder's a lot what? It's a little bit, it's a different shape. It's narrow, but this is wider over here in different places. So it looks, sometimes it looks deceiving. These are the same exact volume. Because this is a little bit thinner. If I pushed it down, it would take this shape. See how this is thicker? So it's taking up the same amount of space in this big room, but just in a different shape. All right. So when you measured length, width, and height in the block. When you measure in the graduated cylinder, because water adheres to the sides like Spider-Man, See how there's water drops up here? There's water drops. Water has an adhesion property. It like sticks to things. Right? You get out of the shower, you still have water on you, not automatically dry. Water sticks to you. So water's going to stick to the side of the graduated cylinder, and it's not going to be level. So it makes this little smile called the meniscus. No, it's really called a meniscus. The meniscus is the curve that the water makes as it adheres to the sides. In the GC, what does GC stand for? Do I have to write it all out? What does it stand for, Ashley? Graduated cylinder. If you don't know what GC stands for, write it. Graduated cylinder. Adriana, what's the meniscus? Just read it. Yes, the curve the water makes in the graduated cylinder. So, if you've ever done any baking, helped your parents bake, when you go to Family Consumer Science and you're going to bake, she's going to say, fill up the cup with sugar. You can't look at it like this because you're not going to know if it's 1 cup. You always have to go eye level to look at the measurement. So when we do the activity on Monday, you're going to have to look eye level so that you're able to be accurate. So you must read the graduated cylinder eye level and at the bottom of the meniscus. Now, the plastic ones don't make a lot of meniscus. Can you see it's like a little curve in here? It's not straight across. There's a slight curve. If you read it at the top of the meniscus, you're reading all the empty space. So you have to read the bottom of the meniscus so you don't read the empty space. We're going to be reading the graduated cylinders on Monday. So in order to understand how to read them, we need to practice first on the paper. So we're going to look at the bottom of your paper or the side, and you're going to look at the scales. When we use the ruler, there were centimeters and little nose hairs. What were those little nose hairs called?
Nose hairs?
What's small in a centimeter? Connor? A millimeter. On the graduated cylinder, there are different units. These are all milliliters, and then the other ones are a little bit smaller than the milliliter. So you have to figure out what the scale is. What are we counting by? So both of these graduated cylinders are 0 and 20. You see them? But this scale is different than this scale. When I talk about scale, I'm talking about what does each line represent. So you see the big lines are tens, right? But the little lines, what do they stand for? So let's look at this. If I'm going from 0 to 10, what does each little line in the middle represent? What are we counting by? If we're going up the scale, are we going to count by 1? Let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like we're counting by ones. So each line would be 1 milliliter. Is this scale the same? The second one, is that scale the same scale?
No.
Let's see. If we're counting by ones, I should do the same thing. 1, 2, 3, 4, 5. No. This would be 1, 2, 3, 4, 5. That says 10. That's not the same scale. The scale is different. What is the scale? What does each number represent, Sequoia? Twos. How do you know?
Because if you count by 2, 2, 4, 6, 8, and 10, and also if you do 2 times 5, that would be 2.
Perfect. So there's 2 ways to do it, Sequoia said. You can do trial and error. Count. 2, 4, 6, 8. You got it, 10. Or you could see that in between here, to get to 10, there are 5 lines. So 10 divided by 5 is 2. We're counting by 2s. That's another way to do it. You can actually do math. Go figure. All right. Your paper is a little bit cut off on the bottom. So you're going to have to maybe look at mine. These are 2s. Can you read these graduated cylinders? Let's practice. Practice reading the graduated cylinders. So your paper, your 20 is cut off, right?
Yeah.
All right. So the first one you can't even see. Can you see the second one? Yes, you can. Make an inference. You can't do this one. This one you can't see, but you can see this one. You can see where the water goes. And you don't have to. All right, look, you don't have to see. All you have to see is this line right here. So you don't have to worry about what's down here. You just see this. So you see that's 35 and that's 40. So what does this graduate cylinder read? This is what the liquid is. Antonio, how much is it? Let's see. That's 35. That's 40. So there's 5 numbers in between. This is 30, what? 6, 37, 38, 39, 40. So what would the liquid be? It's right here. Is it at the 37 yet? It's in between the 36 and the 37. So what number is in between 36 and 37? Yes. Write your answer on the top. Capital M, lowercase m, capital L. This graduate cylinder we're counting by ones. This one we're not counting by ones. Do you see the numbers? This is 5, and that's 6. So what are we counting by? All these little lines are going to be what? What are they going to be? They're going to be 0.1s. So if this is 5, this is 5.1, 5.2, 5.3, 5.4, 5.5. What's my label, Gavin? Perfect. Little m, big L. All right, do this one by yourself. This one's easy, right? Do you need my paper? You can do it on yours.
Sure.
Andrew, you got it? Good, Gavin, you do it. What is it, lemon squeezy? Let's see. 10, 11, 12, 13, 14, 15. Rockstar. Naked numbers, Jordan. Naked, not naked.
ML.
Little m,
Big L.
big L. Good job. All right. Everybody at home, go to packet page 20 and 21 and complete it. That's what they're going to be doing.